Hi everybody, here's going to be your note for 4.2 relating standard and vertex forms, and we're going to go from standard to vertex forms by completing the square. So standard form, like we learned in 4.1, has very limited information about the function. Remember, our standard form is this: ax squared plus bx plus c. You can only really know so much from just standard form equation, but then we learn from our vertex form of the same function, there's much more detail. The vertex form gives us the optimal value, which is the max or min value, also the vertex, and when or where that value occurs, which is particularly useful when solving problems. So remember, our vertex form is this. Where h and k represent the x and the y of the vertex. So to convert from standard form to vertex form, we use a method called completing the square, which we're going to learn about right now. But in order for us to do this, we have to know one other thing. So we'll have to remember one thing from when we learned about factoring. There was some special cases that we learned with factoring. So I want you to look at this part, the x minus h squared. If I were to write that over here, keep in mind, depending on the value of the axis of symmetry or the x part of the vertex, this h value can be positive or negative. So I'm just going to show that with it's a positive or negative sign. Well, when it's x plus or minus h squared, we learn from factoring that this is the same as this special case of a plus or minus b squared, and that is equal to a squared plus 2 times ab plus b squared. This was our special case when we were factoring. So what we're actually going to do is we're actually looking to get this form. Once I have this form, I can go to this form where it becomes a perfect square, so it factors nicely to this form, and then when I have it in this form, it'll help me find the vertex. So our goal is to get this, so that it helps us get it into vertex form. So that's what we're going to use with our techniques right now. The really good part is if you don't understand what I just said from this to this to this, don't worry about it. If you do understand, it'll help us a little bit, but as long as we can follow the steps, as long as you follow these steps to completing the square, and we'll practice it a bunch of times too in this video, you should be okay. You'll be fine. You'll learn the technique of completing the square. So here's our example. I'm just going to block this off. It says write f at x equals 2x squared plus 12x minus 5 in vertex form, and this is currently in standard form. I know it's in standard form because it looks like this equation, and there's like no brackets or anything, so it can't be in vertex form, and there's no factors, so it can't be in factored form. So first thing is we're going to common factor the coefficient of x squared from the first two terms. So this means the coefficient. By coefficient I mean just the number. Number only, not the letter. So if I have f at x 2x squared plus 12x minus 5, if I common factor out just the coefficients, just the numbers from the first two, the biggest number I can common factor out of just the numbers is 2. Because I can divide this one by 2 and I can divide this one by 2. And I can't do anything higher than that because the biggest one is 2 here. So I'm going to be left with x squared plus 6x minus 5. So I just common factored the coefficient, the numbers only, of x squared from the first two terms. So the first two were these two, I just common factored the number out of these two. Next I'm going to add and subtract the square of half the coefficient of x inside the brackets. Oh man, what does that mean? There's a lot. There's a lot in that sentence. So let's do this together. So I'm just gonna write what we had over here. Just gonna write it again over here. We just have to break apart that sentence. Minus 5. So add and subtract the square of half the coefficient of x inside the brackets. Let's work at this end and work this way. So coefficient of x inside the brackets. So coefficient of x. Well, here's our x term right here. The coefficient, we said, just represents the number. So I'm going to get the number. I'm just going to move it out here. It's just me doing a side calculation here. I'm going to look at this coefficient here. I'm going to half the square of it. The square of half. Ugh. So I'm going to get my coefficient. I'm going to half it. And then I'm going to square it. And then that gives me 6 divided by 2 is 3 squared, which is equal to 9. So I'm going to get 9, and I'm going to add and subtract it inside the brackets. So it's going to become, after all that, f of x equals 2x squared plus 6x. Then I have 9 here. I'm going to add it and subtract it inside the brackets. So why are we doing all of this? Why did we want it like this? Well, the reason why we want it like this is because what we want to do is part C is group the 3 terms that form a perfect square. So I'm just going to write this out again. So we did this step to force basically this equation to be in this form. Because if you notice, I can use my special cases here with just these first 3 terms. I can take the square root of x squared, which would be x. I can square root the c term here, which is 9, to get 3. And then if I multiply these and times it by 2, I get 6x. So we've made a perfect square by doing this, so that it can become this form, which will help us get to vertex form. So I group them like this, so it forms a perfect square. So after we have this, we notice we still have this part inside the brackets that doesn't really need to be there. So what we're going to do is, for part D here, is distribute the common factor and move the 4th term outside the brackets. So I'm just going to show that up here, what we're going to do, then I'll put the final kind of thing down here. So we have f at x is equal to 2x squared plus 6x plus 9 minus 9 minus 5. The thing is, I want this by itself, because that is our perfect square, which makes us put it into kind of this form. So I want to get this negative 9 out. I'm going to move it outside of the brackets now. I guess it's kind of confusing how I did it this way. This was just a calculation to know what to put in here. But now I'm actually going to move the negative 9 outside of the brackets. But my rule is, if I'm moving the negative 9 out of those brackets, I have a common factor here. Anything leaving the brackets has to be multiplied by that common factor. So I'm going to multiply it by 2 when it comes out. So then it becomes down here, f at x is equal to 2x squared plus 6x plus 9 minus 5, and then negative 9 times 2 is negative 18. And that would just simplify. So what does this simplify to? Remember, this is our perfect square, so if it's like this, it's going to come into this form, where a and b are just the square root of the first term and of the last term. So the square root of the first term is x, the square root of the last term is 9, is going to be 3 squared. Because it's repeated. X plus 3, if I were to factor this, I would get x plus 3 times x plus 3, so the same thing squared, and then subtract these, minus 23. So now it's in vertex form. This is my vertex. Negative 3, negative 23. The sign is opposite of what it is inside here. So that's how we complete the square. Again, it sounds like a lot. It looks like we did a lot of math here. But once we get into it a few times, you're going to see it's not that bad. Don't let all these words and steps fool you. Don't even let this part fool you, because we just have to follow kind of these 4 steps. So it says express each in vertex form by completing the square, and then state the axis of symmetry and the coordinates of the vertex. So I'm just going to zoom in a little bit. So it says y equals x squared plus 4x. So what was our first step? First step was to, if you look up, I'm not going to look up, fine. Common factor. So we're going to common factor the first 2 terms. Just the number though, remember, common factor the number from the first 2 terms. Well, there is no number here. There's no number there, so step 1. Common factor first 2 terms. And luckily in this question it's already done for us. We're going to have y is equal to x squared plus 4x. I'm still going to put it in the brackets though. I still want to do that because I still want to do my steps inside of the brackets. So y is equal to x squared plus 4x inside of these brackets. Step number 2. This was number 1. Step number 2. This is when I get the x value. So we get the one with x, just the number though. We divide it by 2, and then we're going to square it. So I just kind of do it on the side here. I drew the arrow, but maybe I won't draw the arrow this time. We're just going to get our x term, 4. Do like a dotted line to show that it's not part of the equation, it's just a side equation. Divided by 2, squared. 4 divided by 2 is 2. Squared is equal to 4. So then I'm going to get this, and I'm going to add and subtract it into the brackets. Add it into the brackets, subtract it into the brackets. So, step number 3 is we want it in our special case form of a squared plus 2ab plus b squared. So step 3 is group the 3 that we want together, which in this case is just the first 3, and the fourth one is the one that we kind of move out. And if I move it out, I multiply it by the common factor, but since it's just a 1 here, I'm going to multiply by 1 so that it becomes x squared plus 4x plus 4 minus 4. And then step 4 is just to simplify this. So if I had to subtract anything, I would do it here. And this, sorry, I should write that, simplify. And this part, our perfect square, can become x plus 2 squared, and then the minus 4 stays there. And I got this by just factoring this, x squared plus 4x plus 4. I could think of 2 numbers that multiply to give this and this, and add to give this, sorry, so multiply to give this number, add to give this number, then it would be 2 and 2. So really this is x plus 2 minus 4. So together though they make x plus 2 squared, but either way this is my vertex. So it says over here, what's the vertex? Vertex is the opposite sign of what's in here, negative 2. This value is, it is what it is, so it's minus 4. And the axis of symmetry, remember, is just the x value of the vertex, which is negative 2. So the key to doing this is just like factoring, you just got to practice it a bunch of times. So let's do it again. Here we have in standard form, we're going to put it from standard to vertex form by completing the square. So step number 1, I'm not going to go back to that other page. I know what I got to do is I have to common factor the first 2 terms. I'm not going to write it all this time because I just have to refer back to my sheet. So I'm just going to write the simple step of just common factor the first 2. So if my equation was this, just rewrote it from above, I'm going to common factor the first 2, just the number, biggest number. So between these 2, -2. Try to common factor out the negative if you can. So we're going to have y is equal to, this is step number 1, -2 x squared plus 8x plus 1. So the plus 1 just stays here, and -16x divided by -2 is +8. So we did all that work to put it in vertex form, so I have my vertex, remember, is this and this. So it's the opposite sign from here though. It's going to be the x value of the vertex, and this number is going to be exactly what it is. It's the y value. This is h and k. Remember our vertex is h and k. So -4, 33, and the axis of symmetry is just the -4. Alright, let's keep going. So, oh, yeah. So we see a fraction here. So before we get to this one, I just want to make sure that you actually understand this one. So if you're like, yeah, I get this, then you can skip ahead, but I'm going to do a couple, or maybe just, we're going to do a secret question over here where we're just going to practice this again. So step number 1, I'm not even going to, this time, I'm not going to even write down what to do the steps, I'm just going to kind of label the steps as number 1, 2, 3, and 4. So step number 1, what am I doing? Well, we have this, I'm just going to rewrite it. So I'm going to just common factor the first 2. There is no number there, so I'm just going to put the first 2 in brackets, like that. Then step number 2 was when I do the thing in the middle, where on the outside here, I get the 16 divided by 2, and then square it. 16 divided by 2 is 8 squared, which is 64. So I'm going to add and subtract that. Add and subtract that inside the brackets. Now, for step 3, I want to simplify things by just getting our perfect square by itself. So I'm going to move this 64 out. So move this out. I'd multiply it by the common factor in the front. Again, there's no number here, it's just 1. You can put the 1 if you want, but I'm going to multiply it by 1 so that it becomes x squared plus 16x plus 64 plus 9 minus 64. We then simplify the rest of this as the last part, where I'm just going to simplify my perfect square here. Square root of the first one is x, square root of the last one is 8. X plus 8 squared, and then plus 9 minus 64, or positive 9, sorry. I get -55. So my vertex would then be the opposite sign of this, and -55. So that's our answer. So let's, you already saw it. Another secret question. Let's try it one more time here. I'm going to do a few less steps than what I did over here, because there's a lot of steps I'm showing, like I'm showing this twice, so I'm going to try and condense it a little bit. So step number 1. Just going to rewrite it out. Again, if you need to pause the video while I'm writing, pause the video, write it down, and then unpause it, and then you can see what I'm going to do. It's a very bad 7, but it is a 7 nonetheless. So I'm going to do this. I'm going to common factor the first two terms, and again, just the number. The biggest number is 3. Now I know I said divide out the negative. I'm really just going to do it for the first term, the x squared term. If this is negative, then I common factor out a negative. If it's positive, then I'm just going to keep it positive. Because you'll notice for all of our things up here, it's always x squared is positive. So I always want it for x squared to be positive. So I'm going to common factor out a 3. I'm going to bring that to the front. X squared minus, well, negative 24 divided by 3, 8x plus 7. Much better looking 7 there. So I have 3x squared minus 8x plus 7. So step number 2 is that middle part. I think I'm just going to write all the steps again. We get negative 8. It's negative 8 here. Negative 8 divided by 2 squared. Negative 4 squared. Using a calculator, negative 4 squared is, move my paper, is 16. So I'm going to do this. I'm going to add and subtract it inside the brackets. Plus 16 minus 16 plus 7. Step number 3 is I'm going to just get the perfect square by itself. This one, the first 3. So I got to move this one out. So 3x squared minus 8x plus 16. Moving this out. And again, I have to multiply it by the coefficient in the front, which is 3. So times it by 3 because I'm moving it out of the brackets. And I'm going to get 3, I'm just going to move this up, x squared minus 8x plus 16 plus 7. When I moved it out over here, times it by 3, I get negative 48. Which then gives me, if I simplify it now in step 4, my perfect square. And the last one is 4. Oops, made a mistake in that. Because it's minus here, it should be minus in here as well. And then positive 7 minus 48 is, thank you very much, is negative 41. So I completed the square again. So a bit of a trick, if we see that this, this is the middle one is a negative, I should have a negative here. And why is that? Well, I could turn this back into standard form if I wanted to, couldn't I? Let's just do that down here. You don't have to copy this if you want, but it's just to prove that this is going to become our original equation, like up here. Well, how could I do that? Remember, this is actually from 4.1. If I were to expand this out, put a little line there, I would get 3x minus 4 x minus 4 minus 41. Don't worry, this x minus 4 squared is the same as x minus 4 times x minus 4. So if I were to FOIL this, I would get x squared minus 4x minus 4x. Negative 4 times negative 4 is positive 16 minus 41. Collecting like terms, I get this. Now I'm going to use distributive property here to multiply this into all of them. I get 3x squared. Oh, I gotta move this up. There's doing so much math. Running out of space because there's so much math. 3 times 16 is 48 minus 41, because once I expand this into the brackets go away, and then I subtract these two, I get 3x squared minus 24x plus 7, which is what I started with. So that's how I noted it correctly. So if the second term is a negative, even here, it's going to be negative in here. That's inside the brackets, because I might have to common factor out a negative. So So yeah, depends on the case, but if inside the brackets this is a negative, it'll be a negative here. If it's a positive inside the brackets, it'll be a positive for this last step. Alright, now let's get to the fun one with the fraction. Step number 1. Again, I'm not going to write the words, let's just do the steps. So I'm going to common factor out from the first two terms here. So the biggest number I can common factor out, well, you see the fraction. Nobody likes fractions. Well, most people I talk to don't like fractions, so let's just common factor out the fraction. So we're going to common factor out negative 1/3. So I'm going to get negative 1/3 on the outside. This divided by this, well, it's the same thing, it's just going to be x squared. And then plus positive 3x divided by negative 1/3. If you're like, oh, I don't know how to do that, well, we can remember our principles for dividing fractions, or you could just use your calculator with the fraction button, or you could use the whatever form of technology you want to divide these. But if I did 3 divided by negative 1/3, that's the same as 3 times the reciprocal, which is going to be negative 9. So it's going to be not plus, it's going to be minus 9x minus 4. And if you're like, how do you know that? Well, if I were using distributive property here to put it back in, negative 1/3 would be times this is x squared, negative 1/3 times negative 9 would give me positive 3. So I've done it correctly. So then, my second step is to get the second term, the x1, and do that thing where we divide it by 2 and square it. So, the annoying part here is that we're going to have a fraction. So can you use a fraction or a decimal? You should be using a fraction. If you don't like fractions, you have to either use your calculator and your fraction button. So if I were to do this, I would know that this is the same as (81/4), because I just multiply the top parts and multiply the bottom parts. These are 9s. So I'm going to get this number, and I'm going to add it and subtract it inside the brackets. And you're thinking, well, there's now more fractions. Why is there more fractions? Well, that's as difficult as it can get. Well, it could be more difficult, but again, we got to give you some tougher questions. So we're going to add and subtract that inside the brackets. There we go. So step number 3 was get the negative 1 and move it outside. So we're going to show that step. We're going to move this one outside, and the other rule we have to remember is we have to multiply it by the common factor in the front. I was pausing for, hoping somebody would be yelling it out to the screen. So times negative 1/3 when it moves out of the brackets. Sorry, a bit of a technical glitch there. So we're going to multiply this by the common factor in the front. I think I said that about 4 times. But let's do it again. I'm going to use my calculator with my fraction button to help me out. So negative 84/4 bracket. I just put it in brackets just to be safe. I'm going to multiply it by 1/3, and I'm going to get 7. So I get plus 7. So this times this is 7. And now, believe it or not, this is still my perfect square. So I'm going to simplify that. What's the square root of the first term? X. Square root of the second term? Well, let's do it on the side. If I find the square root of 81/4, that's the same as the square root as the top and the square root of the bottom. It's going to be 9/2. So I'm going to have 9/2 here. The middle term is negative, So this will be a minus, so minus 9 over 2 squared. And then simplify these two. Negative 4 plus 7 is 3. Oh man, okay, so we've done a lot. We've done a bunch of examples. So let's get to one word problem, then we're home free. So for this one, what I'm going to do actually is I'm not going to write out the numbers of steps. I'm just going to do it as if I were actually, this is how I'm just going to answer it. So it says the cost of operating a cement truck is modeled by the function, this equation, where n is the number of minutes the truck is running. What is the minimum cost of operating the truck? After how many minutes does this occur? So I'm just going to rewrite the question, or the equation, sorry. Not the whole question, that's a waste of time. But the equation takes like 10 seconds. I'm writing really slow. And I'm making mistakes, so it's a little bit longer. Okay. So, one says, what is the minimum cost of operating the truck? As soon as I see the word minimum, what does that tell me? Well, the minimum has to be, on a graph, the lowest point. Minimum, remember, if I have a parabola, the minimum is the lowest point. And look at my equation, it's a quadratic, it's positive, so it's going to be going down like this. And this is the minimum, the lowest point. And the lowest point in this case, what do we call this? We call this the vertex. Sorry, I was trying to do fancy cursive writing, but vertex. So it's again the lowest point. This is the vertex, the minimum here. So we have to find the vertex of this equation of the 2.2n squared minus 66n plus 700. Once I find the vertex, I found the lowest point, which is the minimum. But how do I find the vertex from that equation? Well, with today's thing, we just learned how to complete the square. So this is my mindset when I see a question like this, as if I know my techniques for the chapters. Well, the question says the minimum cost. We've seen minimum and maximum so many times in the past, this chapter and the last chapter. So the minimum or the maximum is the vertex, the highest or lowest point. And to find the vertex from this form, we could have factored it, put in factor form, did all that stuff from last chapter, or we can just complete the square because it takes less time. So I'm going to complete the square now, and I'm just going to do it without outlining the steps as much. I'm just going to do it. So I'm going to first common factor the first two. So I'm going to get n squared minus negative 66 divided by 2.2 gives me 30n. So I common factor the first two. Then I'm going to do the thing where I get the middle one. I'm just going to do it over here. Negative 30 divided by 2 squared gives me negative 15 squared, which is 225. I'm going to add that, subtract it, and then I'm going to move it on the outside after. And when I move it to the outside, I'm going to remember, going to multiply it by 2.2. I'm going to write it in there. Just takes a second to help me remember. I get plus 700 because that's this part. And when I move it out, I times it by 2.2, and I get negative 495. And I'm going to double check that because I want to make sure that that is correct. Yep, so it's negative 495. And now we just simplify it. Square root of the first one, n. Square root of the last one, 15. Oh, it's minus 30 here. Should be minus here. You can also think of it by getting this term and dividing it by 2. So I get this, and then to simplify the outside, that would equal 205. So this is the vertex. So my vertex happens at 15, 205. Now what do these mean? We have x and y. They said n, well that's the part here, this is usually with the x's. X, or n, is the number of minutes, so at 15 minutes. The minimum cost, that's all of this, CNN, is 205. So therefore, the minimum cost is $205 at 15 minutes. So that's the word problem. So again, completing the square, do the same steps again and again and again. Look at the steps, watch the videos, and hopefully that's enough. And try this homework. So thank you very much for your time, and yeah, have a good